So we have two arc length formulas, and arc length is S, which is this part of the circle. And our first formula is when theta is in terms of radian measure. So it's going to be arc length equals the radius times theta in radian measure. Or if theta is in degree measure, then we have an extra step in there where we're going to take it times pi over 180, basically converting it to radian. But no matter which one you choose, both will give you the same answer. And we will want to give our answer in two forms, in simplest form in terms of pi, and then we can do a decimal approximation as well. Okay, so let's go ahead and do a couple of problems where we're finding the arc length of each sector. Okay, so our angle is in radian measure, so the formula for arc length S is going to be R times theta in radian, right? So we have our radius is 24 meters. We don't need to do any converting because that's the only unit of measure that we have for length right now. So 24 times theta in radians, so we would put that as 11 pi over 6. Then we'll want to reduce that. 24 is the same as 24 over 1. So 6 goes into 24 4 times. So we can reduce that. That gives us 1. Here we have 4. And that would give us 44 pi meters. So there's the first form for the length of our arc for that sector. And then if we wanted to do a decimal approximation, you just take 44 times pi on your calculator, and let's go to the nearest tenth. And 138.2 meters. 138.2 meters. So each type of answer different problems will lend themselves to wanting to state the answer in a different way. So I would prefer you put in both forms, reduced pi and then as a approximation. Okay, because our angle is in degrees, we use a different formula. So arc length is going to be radius times theta in degrees times pi over 180. So we know our radius is 6. Our angle is 50 degrees. So I'm going to take that times 50. And then I'm going to take that times pi over 180. And again, I want to leave it in terms of pi initially. So we are basically reducing 300 pi over 180. And what do we get when we do that? 5/3? And that would be centimeters. And then the approximation, did you get that too?
5.2.
So 5.2 or 5.3?
5.2.
5.2. There we go. Okay, so sector area is going to be part of a circle. So arc length was just like this part of the circle. Sector area is like a piece of the pie of the circle. So it's part of the area of a circle. So when we're talking about sector area, it's about as good as I can do in terms of shading that in. We are talking about part of the area of a circle. So what's key in that is knowing the angle, the central angle right here. that that arc opens up to, and then that the circle is, and then we also need to know the radius. So once we know the theta, central angle, and the radius, then we can plug it into either formula depending on if theta is radian measure or is in degree measure. Difference between this and arc length is we're going to square our radius, and then we're going to take half of that times our angle. Okay, so our angle, central angle is in radian. So in order to find the area of that sector, we're going to use 1/2 r squared theta radian. And so we have 1/2 our radius. All right, so it gives us a diameter of 8 feet. What does that mean the radius is? 4. It's half of that. So we're going to square 4, multiply it by 1/2, and then we're going to take it times our central angle of 7 pi over 8. And again, I would recommend that you put the answer in both forms in terms of pi reduced or simplified, and then as a decimal approximation to the nearest tenth. So when I do this, I get 1/2. 4 squared is 16, so half of 16 would be 8. So I have 8 over 1 times 7 pi over 8, and the 8s will reduce, and I will get 7 pi. And it would be 7 pi feet squared, because we're talking about an area. And then the decimal approximation, 7 times pi, what do we get? 22? 22.00 feet squared. So both of those would be acceptable. Well, I want both. So radius is 8 inches. What's our central angle? 1 full is 360, but we have how many pieces? 8. So we take 360 divided by 8. That is 45. So our central angle is 45 degrees. So we're going to use a formula that involves theta d, theta in terms of degrees. So our area is going to be 1/2 our radius of 8 squared times 45 degrees times pi over 180. So a whole lot going on there. 45 goes into 180 4 times, I think. Anybody agree with me on that? 45 times 2 is 90, so yeah. So then 8 squared is 64, half of 64 is 32, 32 divided by 4 is 8, so did you get 8 pi? Okay, and that would be inches squared. And then 8 times pi, 25.1 inches squared. So that's how big of a piece of pizza that you're eating there. Next time you go for pizza, I expect you to measure the diameter and then determine what this area is of the piece of pizza that you're eating. Okay? Actually, we should probably do that like as a